we are moving to chapter 8. I know we haven't done chapter 7 yet. Chapter 7 is very, very, very short, but I need 2 days to do it, and I don't want to start it today, have your test on Monday or Tuesday, and then try to get back to 7. I just going to start with 8. We're going to get all of chapter 8 done, and if we have time at the end of the year, we'll come back to 7. I think we will. But if there is a section that we don't need as much, it's going to be chapter 7. So I'm going to put it on the back burner for right now, at least. Okay. So we are going to go to chapter 8. So you're going to skip a chapter, and the page that I want you to go to looks like this: Pythagorean Theorem. Can you get this in front of you? It's one of the first pages of chapter 8. I believe it's the 3rd page in. I think you have a formula page, and then you've got chapter 8. So just let me know that you've got it in there, that you found it, at least one of you, and then I know that the rest should have it.
Yeah.
Okay, all good? Now, here's what's going to happen. I'm going to do a PowerPoint presentation on the Pythagorean Theorem, okay? I think a lot of you probably know the term Pythagorean Theorem, whether you remember what it is or not, but let me just real quickly tell you what the Pythagorean Theorem is in my own words. Here's what the Pythagorean Theorem is. Give me a right-angled triangle. It's got to be a right-angled triangle, and then tell me 2 sides. I will always be able to figure out the other side. Give me a right-angled triangle. Tell me 2 sides. I'll be able to tell you what this other side is. There's a relationship in right-angled triangles where as long as you know 2 of the sides, you can always figure out the other one. It's called the Pythagorean Theorem. It's a fancy name for saying, give me 2 sides of a right-angled triangle, I'll figure out the other one. So you guys are going to start with this very first slide. You've got to write into this first slide where it says Pythagorean Theorem. You've got to write in there, and I'm going to do a PowerPoint presentation here leading you through, okay? So just give me 1 sec here, and anything you see, I want you to write onto your page. So this is the top left slide, the very first slide you've got to write in, okay? So you should see Pythagorean Theorem at the top. I'm looking at mine right now, and you see this triangle. Now your triangle is more in the middle. Mine's off to the side a little bit, but let's just write out a couple things about the Pythagorean Theorem. Here's the first thing. Up in the top right, the Pythagorean Theorem is a formula, and it's the formula c squared equals a squared plus b squared. But we've dealt with equations, and we know we can move equations around because there's another way to write this. And what we can do is, do you see how I move this a to the other side? Brought it over with the c. This a squared becomes, flipped it around. I got the b squared by itself. Bring the a squared to the other side. These are both the Pythagorean Theorem. These are the 2 formulas we are going to use in this PowerPoint. Okay. So we have to know which side is the hypotenuse. And there's 2 ways to kind of find your hypotenuse here. Which side is the hypotenuse? And here's what we're going to learn here. 1, it's across from the right angle. And 2, it's always your longest side, and it's labeled C. And you can see I put an arrow to it right there. So it's across from the right angle. Notice it's the only side not touching the right angle. This side touches the right angle right down here, and this side touches it. It's the one across from it, and we label it C. It's our longest side. Give you a second to copy that out. Are we okay there?
Yes.
Anybody need a little more time? Real quickly, c squared equals a squared plus b squared, or b squared equals c squared minus a squared. And I'm going to kind of refer to these two formulas as the one with the plus sign and the one with the minus. The hypotenuse, notice the spelling, hypotenuse, hypotenuse, hypotenuse. It's across from the right angle. It's always your longest side. So when we go to our next slide, you guys have a triangle that looks like this. Okay? You can put your arrow if you want to show your hypotenuse. Now, when you are calculating your hypotenuse, when you are trying to find your longest side, it only makes sense that you are going to use the formula with addition. You want to get bigger. It's your longest side. So with the two formulas that we just learned, if you look at the slide next to the one we're doing now, you want to use the one with the plus sign. You want to get bigger. So here's the formula you're going to use when you find the hypotenuse of a triangle, a right angle triangle. So what is c squared? Well, it's just going to stay c squared. The a and the b are interchangeable. So I put 8 first, squared, and I put 6 squared. So now, in your calculators, 8 squared plus 6 squared should leave you with 100. And I'm going to escape here for a second. You can still see what's going on here. So in your calculator, 8 squared plus 6 squared. Hopefully you can see that. And when I hit enter, do you see how we get 100? So c squared, notice it's still being squared. C squared is equal to 100. That's your next step. But here's where we're headed. How do you undo addition? You subtract. How do you undo subtraction? You add. They're opposite operations. Multiplication and division are opposites. In the opposite of squaring something, you see on your calculator here, this x squared key? The opposite of squaring is square rooting right next to it. So on your calculator right here, this key, we're going to hit square root, and notice it's waiting for the number. We're going to put in 100. This gets rid of the squared. Your c squared goes to c, and I hit equals, and I get 10. This means that 10 times 10 is equal to 100. We learned about exponents. Square root is the undoing of a square. Is that okay with everyone? Now, you get an answer of c is equal to 10 on a quiz or a test, on your exam, whenever. You look at this diagram and you say, yes, it makes sense, or no, it doesn't. When I look at this, I say, this makes complete sense to me because isn't our hypotenuse our longest side? And 10 would be my longest side. It's not absurd. It's not like it's way out in left field like 100, 8 and 6. 100 would be way too big, but 10 is right in this ballpark, and it's bigger than both of them. I know this is right. Okay, is that okay with everybody? Just going to go back, previous slide. Is everybody okay with this first one? So to sum up,
how do you know which one's the A and the B, the 8 or the 6?
The A and the B are interchangeable. If you would have put 6 here and 8 here, it just would have been 6 squared, which is 36, plus 8 squared, which is 64, and when you add them together, you still get 100. The A and the B are interchangeable. It doesn't matter which one you pick for A, pick the other one for B. It's not the case with C. C is always the hypotenuse, though. Does that make sense? So find your right angle, go right across from it. This is always your C value. This is always the hypotenuse. But these other two are interchangeable, and you'll see that on the next page here, okay?
All right.
So when you have this triangle here, where's your right angle? Well, it's right here. So across from it is your hypotenuse. This is my hypotenuse. Do we know our longest side? And in this time, I would say, yes, my hypotenuse is my longest side, and I know this. So are we going to use the formula with addition to get even bigger? Well, the answer is no. We want to use the subtraction formula. So when you find one of those other two sides, not the hypotenuse, you know the hypotenuse. When you find one of those other two sides, use the subtraction formula. Now, here's where you've got to be careful. And when you ask the question about how do you know which is A and which is B, I said they're interchangeable. For this, though, this has to be your C. The 12 has to be the C. And then the other two sides can be your A and your B. So we write out our formula, B squared equals C squared minus A squared. And notice I put the B as the variable. Now, what am I going to plug in for C? What do I have to plug? The answer is 12. What do I have to plug in for the A? The answer is 7, because I need my numbers on this side. But what am I going to plug in for the B? Technically nothing, but in the diagram, notice they gave us an X. This is where you set yourself apart from other people. Don't put B squared equals, change it to X squared, because that's what you're finding. Do you see the change here? B is actually X squared equals 12 squared, take away 7 squared. So in your calculator, go 12 squared, take away 7 squared, and hit enter. Write down what X squared equals. And then use your square root key to figure out what X equals, because all you did was figure out X squared right now. So I got X squared is equal to 12 squared, which is 144. Take away 49, which is 95. That's X squared. Use your square root key, and when you take the square root of 95, you get 9.7. Now, 9.7 is the length of this side. Notice I knew two sides, and I figured out the other one. And this makes sense to me because 9.7 isn't my biggest side, but it shouldn't be. 12 should be my biggest side. So I'm good to go. Is everybody okay with this example? All good?
Yeah.
All right, I'll give another 30 seconds just to copy this out, and then we're going to move to the next one. Kind of really interesting on the next slide. I want to bring something to your attention, a real life type situation. All right, next slide. The length and width of a rectangle are 12 and 15. Calculate the length of the diagonal. Okay, well, you have this rectangle sitting in your screen on your handout. Let's label the sides like they told us, 12 and 15. So the longer one, the bottom one is 15, the side is 12. When they talk about a diagonal, they talk about a line going through the middle of a rectangle. That's called a diagonal. And they want to calculate the length of that. Now, this is a rectangle, but when you take a look, do you see how you actually have a right angle triangle down in this bottom corner? There's your 90-degree angle right here, and we're trying to find our diagonal D. Ask yourself, do you know the length of the hypotenuse? Do you know the length of the longest side across from the right angle? And here's your right angle, and I would say, no, we don't. We know the other two sides. So what are we going to use? The one with addition or the one with subtraction? We're finding our biggest side, the hypotenuse. Use the addition formula. You guys plug in, solve, see if you can get the length of the diagonal, and see if it's your longest side. I'll give you a minute to do that. careful here. My C, I'm going to put in the variable D, because that's what I labeled it in my diagram. Okay, you're not going to get it wrong. It's just about being precise again. Precise, you should put D here. Now, the person that asked the question, it doesn't matter because you're adding. It doesn't matter whether you put 15 here or 12. Just put the other one here. It doesn't matter because 15 squared and 12 squared, it doesn't matter which way you add them, you'll still end up with 369. Now, what we want to do is we want to undo this. So we take the square root of 369 and we end up with 19.2. 19.2 is in the range of these numbers, and it is our biggest side. I really like that answer. The length of this diagonal, 19.2. Now, the real life question is this, and I want somebody to unmic and let me know if they know the answer to this. There is something in your life, I know for a fact, in your life, that when they tell you the measurement, they tell you the diagonal measurement. Does anybody know what that is? There's two things.
Would it be like a bedroom? I'm not sure. Like if you're like measuring out like a house.
You could, in a way, in order to square things up, but that wasn't what I was thinking of. Like for you guys, a bedroom, like what was that?
A TV.
A TV is a prime example. When you talk about an 84-inch television, the 84 inches is across the diagonal. Now, I think it was Owen there was talking about house plans. Yes, that is for sure involved in house plans. That's more for like a designer, like an architect, coming up with those. For you guys, I think you're more into TVs right now. Okay. Does anybody know the other thing? Very similar to a TV. Some of you are probably using it right now.
A phone.
A phone, a laptop, anything electronic. When they talk about the new iPhone 32 is coming out and it's got a 14-inch screen, they're measuring on the diagonal. Any electronic device, when they talk about a screen size, it's on the diagonal. So when you have a laptop, they talk about the screen size, diagonal. TV, phone, etc. My smartboard, even when I got my smartboard, they talked about the size of the smartboard. They measured it on the diagonal. Okay, everybody good? All right, Tanya's making a party hat. Last one here, using a cone. Anybody ever done this? Take a piece of paper and kind of fold it around and staple it. And, I've seen crafts of some sort doing this. You cut the bottom, make almost like a cone. Determine the height of the cone. Well, you guys have some small numbers in here. Hopefully you can read them. But what I want to bring your attention to is this is a three-dimensional shape. This is a cone. But when I go like this, does everybody see how we've got a right angle triangle hidden in there? I'll do that again. I spent all night doing that. Ready? Change color. Look at the blue. Okay, we now have a right angle triangle in there. We know one side is 13. This is called our slant height for an appropriate reason. You see it's on a slant? This is called our slant height. This is our height, which is straight up and down. Height, slant height. And this is actually the bottom measurement within a circle. We call this actually the radius, believe it or not. That's just the radius of the circle. Radius, slant height, and height. We're going to get to this more in chapter 8. You ask yourself, where's my hypotenuse? It's right there. So what I'm going to do is I'm going to bring this out and just treat it. Did you guys see that? Look at the animation on this. I'm going to bring this out of my party. And just in case you missed it, I'm going to do it one more time here. I spent all night doing this. I'm going to bring this triangle out of the party hat. 3 dimensions to 2 dimensions. Now we've got a right angle triangle. Do we use the formula with addition or do we use the formula with subtraction? Just in case you missed it, take a look here. We can bring that triangle right out of the party hat. Addition or subtraction?
Subtraction.
Subtraction.
Why?
Because you're going smaller.
We're finding our smaller side. If we use addition, we're going to end up with a number more than 13, and that's not that side. We use the subtraction formula. Plug in your numbers, make a change of variable too. Okay, see if you can get this answer precise, not just right, but precise, and see what you come up with. What is the height of this party hat? The C has to be 13. It's my hypotenuse. The A has to be the other side I know, which is 5. And I'm going to put an H in where the B is at. Do you see this change of variable here? Because H is in my diagram. I don't have a B in here, I have an H. So when a person reads this line, h squared is equal to 13 squared minus 5 squared, they know what you're talking about with the H. 13 squared take away 5 squared is 144. And now we take the square root and we get 12. Does 12 make sense? Yes or no? Tell me why.
Yes, because it's not the longest side, but it's not the shortest side either.
Correct. The only thing I'm concerned about is not the longest side. What should be my longest side is 13. This is less than 13. It's in the ballpark. I love this answer. I think it's right. Is everybody okay with that PowerPoint presentation? Everybody good there? So hopefully you copied everything out here. Okay. Here's where we're headed. We'll go to the next page. And here's what I would expect for you to do. This says Pythagorean Theorem practice, solving for the hypotenuse. These first 4, notice you're finding the hypotenuse, finding the hypotenuse, finding the hypotenuse, finding the hypotenuse. So there are 4 steps that I want you to show for sure. Here's the first thing when you're given a triangle like this, and I ask you to solve for this side. You write out the Pythagorean theorem. C squared equals A squared plus B squared. I'm using the addition formula. First step, probably worth half a mark. Now, what am I going to put in for the C? In the diagram, it's an X, so I switch to X squared. I don't know why that's a Y, that should be an X. Go like this. Bring this over here. Bring this over here, that should be an X, there it is. So X squared is equal to, now, A could be 12 or 5, it doesn't matter. But then we put the other one in for the B. X squared, X squared, not Y, is equal to 169. And then we take the square root, and I'm sure there's a Y under this one too. I should get X is equal to 13, and in this case, millimeters. Is that okay? You can do this one, this one, this one, all the same way. Okay. That makes sense to me. It's my longest side. The only difference, I'm going to do one more with you right now. The only difference down here, this is solving for another side. Do you see how we know the hypotenuse? So here's what I'm going to do. I'm going to write my formula with subtraction. B squared equals C squared minus A squared. There's my other formula. For the B, I'm going to put in an M, because that's in my diagram. I have to put 12 for the C, and I have to put 8 for the A. 12 squared take away 8 squared. Use your calculator. I ended up with 80. And now take the square root to get rid of the squared. That leaves you with an M. And the square root of 80 is almost 9, right? Because 9 times 9 is 81. It's 8.9, and in this case, meters, because this is in meters. 4 steps to each one. Write your formula, plug in, get what the squared is equal to, and then take your square root. You guys have 6 more to do, okay? Can everybody check the first 4 just to make sure you got them right? In each case, you're solving for the biggest side. So when you answer, your side is the longest side in that triangle. Any questions on any of these? Okay, the next 4, we already did the first one. On all of these, we're using the exact same formula to start because we're finding another side. Here, I'm going to plug in a P, 8 squared take away 3 squared. Here, I'm going to plug in a W, so W squared equals 130 squared take away 55 squared. Here, I'm going to plug in an H, so H squared take away 60 squared minus 44 squared. The next step is the same in each one. Now, 8 squared take away 3 squared, that's what P squared is equal to. In this case, it's 55. 130 squared take away 55 squared, that's what W squared is equal to. And here, 60 squared take away 40 squared, that's what H squared is equal to. And then just take the square root of each of these. Square root 55, I got 7.4 meters. I put on the units on the end because they're giving us the units here. For the next one, this is in centimeters. We take the square root, 117.8. This is less than 130. I'm happy with that. It's not my longest side. And then the last one, I take the square root, I get about 40.8. Now notice, never trust a diagram. This comes up with a great point here. Do you see how this, they say, is 44? And all of a sudden you figured out this other side, and you're like, well, wait a second, this side is longer than this side. How is this 40 and this 44? Never trust a diagram, okay? They probably just sketched a triangle, put the numbers down. They didn't think about how to draw it. This is your longest side. The other 2 are smaller than your longest side. Can I get some thumbs up in that section? Just make sure you guys are good with this. You understand it.
I'm good.
Any ones you want to go over?
No.
No, everybody good? All right, this will be posted, okay? Now, here's the last thing we're going to do today. I'm just going to get you started. I'm going to let you work. Okay, you'll finish over the weekend, and then what you'll do is you'll come back, and when I see you in class, whether it be Monday or Tuesday, I will take up this word page with you, or I might just post the solutions. That's probably what I'll do. I'll probably just post the solutions on Monday, okay, so you can check your work on this. But here's where we're headed, okay? I'll show you a quick video that does a really, really good job of explaining the Pythagorean theorem. If you can watch here for a second. Right here, if you take a look at this right here, just so you guys can see a bit better. This was a science project, and it was done really, really well. So take a look here. There's your right angle triangle. This is your right angle, so this is your hypotenuse. This is C. So if this side is C, then this is now C squared. You see how they squared it? They turned it into a square. This is A, this is B, or this is A, this is B. It doesn't matter. But you see how they took this side, measured it, and they made it into a square? Took this side and measured it and made it into a square. They took each of these sides, measured them, and turned them into squares. They filled this up with water. They filled this up with water. And then here's what their science project is. No words. The water from the 2 smaller squares drains in and fills the bigger square. A squared plus B squared equals C squared. That's the Pythagorean theorem as a visual. A plus B squared is equal to C squared. The amount of water in each of the 2 smaller ones fills up to the bigger one. I think that speaks volumes there. So here's where we're headed, okay? Right now, let me just go like this. here's what happens, okay? This is what you know right now. You're given a right angle triangle, and you guys can use the Pythagorean theorem to solve. This is what you know right now. Give me a right angle triangle, I'll use the Pythagorean theorem and solve, and that's what you just did on that last page. But now here's what I'm going to add. I'm going to give you a word problem, and you have to create the right angle triangle before you use the Pythagorean theorem to solve. Do you see the extra step here? So you're going to create the actual diagram. So here is the worksheet. 5 questions. Everyone deals with a right angle triangle. The very first one, if the legs of an isosceles right triangle are 6 units long, find the length of the hypotenuse. Okay, well, this is a right angle triangle, but it's also an isosceles right angle triangle. What does it mean to be an isosceles triangle?
Two of the sides are equal.
Exactly. So when we make this triangle, here's what's going to go on. I'll just get you started on the first one. This is a right isosceles triangle. Why is it a right angle? Or sorry, why is it a right triangle? I just kind of gave it away. Because there's a right angle right down here. There's your right angle. But this is also an isosceles because this and this are the same length. That's why it's an isosceles. And in particular, these are 6 units long. 6 and 6. You're trying to find your side C, which is your hypotenuse. So you use your Pythagorean theorem. You ask yourself, am I finding the longest side? The answer is yes. So I use the addition formula and I come up with my answer. Each of these all deals with right angle triangles. Okay, so see what you can do. Your homework is to finish this page and also the next page are 2 EQAO questions that deal with Pythagorean theorem. So this one here, the detour in school thing. So you have those next 2 pages. That is your homework on Pythagorean theorem. So this weekend, get that done. And then also make sure you study for your chapter 6 test, either Monday or Tuesday. Okay? Stay online for the next 5 minutes or so. See if you can get a couple of these done, and then I'll let you know when you can go.